Okay, well that took about another minute or so, and you probably didn't want to sit there and watch me do that, but I continued to add more hydrochloric acid until my litmus paper turned from blue to red. So it is indeed acidic now, and we can continue on. We're going to add 1 milliliter of ammonium chloride, so a little less than 1 finger's width of ammonium chloride. And we're going to stir. And then, as we continue on, we're going to make the solution just barely basic using ammonia water again. Now, there's no way to tell if it's just barely basic by looking at the litmus paper and saying that the red paper just barely turned blue. Instead, what this means is that we're going to add a couple of drops of ammonia, stir it and test it. If it's red, it's still acidic. Add 2 or 3 more drops of ammonia, stir it and test it. If it's still red, it's still acidic. 2 or 3 more drops of ammonia to add. Stir it, test it, and if at that point it's turned blue, then we know it's basic and we know it's turned blue within just the last couple of drops. So that's what we're going to do. So I've got some red litmus paper ready, and I'm just going to leave it here on the paper towel. I'm going to add the ammonia, a few drops at a time. You got to be really careful here. The precipitate that you're looking for may disappear completely if you make it too basic, and there's really no way to get it to come back, so you've got to be patient here. Alright, red paper, still red. Let's add a couple more drops. Now the paper's turned blue, so I know it's basic, and since it wasn't basic 3 or 4 drops ago, I know that just in the last few drops it has become basic. Now if we take a look at the procedure sheet, it says that a white or grayish flocculent precipitate means aluminum may be present. So I'm going to bring this around for a little closer look. This precipitate is flocculent. It's fluffy, it's floating there, it's not nearly as heavy as precipitates that you've seen before with things like lead and mercury and silver. It's kind of a jelly-like precipitate that's just floating there, and it's going to take a long time before it settles. So as I centrifuge this, I'm going to need a centrifuge for a longer period of time. So to finish step 8, we're going to centrifuge and decant, saving the precipitate for procedure 9. Now, like I said, this precipitate is not nearly as dense. It would take gravity longer to bring that precipitate to the bottom of the test tube. Even the centrifuge is going to need to be run for a little bit longer in order to get that precipitate all the way down to the bottom of the test tube. So if I would normally let this run at top speed for 5 seconds or so for other types of precipitates, I may let this run for a little bit longer, 15 or 20 seconds, maybe 30 seconds, trying to get all that precipitate gathered down at the bottom of the test tube. So we're going to decant and save the precipitate for step 9. Now, it says that we can discard the decantate, but I'm actually going to pour this into another test tube. Now I'll bring this around for a little bit closer look again. That precipitate now is down at the bottom of the test tube. It's kind of a jellyish type precipitate, and it's not very dense. So as I pour this off to save the precipitate, I'm going to pour the decantate into another test tube. The reason for doing that, rather than pouring it directly into the sink, since this precipitate is not as dense, if I were to accidentally pour too quickly, there's a high probability that my precipitate might pour out with the solution and end up down the sink, and I'd have to start over again or go back to my test tube that I'd saved all the way back in procedure step 5. So if I poured it into another test tube, I could always pour it back in, recentrifuge, and try again. But I was successful here. I poured off the liquid, and I was able to save my precipitate. So I can now discard that solution and save the precipitate for step 9. That's it for step 8. We know we might have aluminum. Let's go to step 9 and confirm that we do indeed have it.